Hello, so we're back in Wisconsin after our summer trip. It's actually fall here now, but I just wanted to do a walk around video and talk about the final build and how our trip went. We did over 11,400 miles over a period of 9 weeks. We went from Wisconsin all the way up to Alaska, spent about a month driving around in the state, and then made our way back south through Vancouver Island. We had a really good trip. Nothing really went wrong with the vehicle, so we were super excited about that. Overall, couldn't be happier with how it performed. We were very pleased with our design, all of the features we added. We did keep a short list of things that we wanted to improve as we went along, and have been working on those, but they're pretty minor and they're just enhancements. You'll have that when you start spending time in a build like this. There's always going to be something that you want to improve on a little bit, but the great news is no major changes. We're going to talk about the truck build. We'll just go from the bottom up and cover some of the main components and how they worked. So these are the DBL wheels. They're a beadlock style, and didn't really have any issues with them. They're just wheels, so it's really not too big of a deal. The tires was a big thing we wanted to try out. These are the Michelins. There's only a few tire choices for the 335 80R20 size, and this is one that's kind of hard to get. It's a nice wide tire and it has really good performance ratings. We had a max speed of 68 miles per hour, so normally I just set the cruise control to around 62 or so on good roads, and that worked out just fine. There's obviously some noise with the lugs on this size of tire, but once they got broken in, it wasn't quite as noisy, and we really didn't notice it that much. The cab's pretty nice and quiet. We have about 12,000 miles on these tires at this point, and we did have one rotation in Fairbanks. Just did the front to back since they flip from front to rear. We weren't able to get our spare tire in the rotation, but that's a different story. As far as tread wear, I think we lost about an 1/8 inch of tread over 7,500 miles. I don't know, I haven't measured to see how much is left on here. I'm hoping we can get good mileage out of these. That's the thing about these tires, is nobody really knows how many miles you get. The tires have worked out really well. We didn't have any punctures. We had one slow leak in one tire, but that was from the O-ring inside the beadlock. And when we got back, we just swapped that out. So on that one, I would just have to touch up the tire pressure a little bit each day. We do have a TPMS system on here. That's just Bluetooth. I can't remember which one it is, so I'll put that in the link for the video here. And that was nice to keep an eye on things as we were driving. This system had an alert on a module inside the dash, and then you could also have it on your phone to find out what the tire pressures were. So you can see we have liquid spring. This is probably one of the best decisions on the whole truck, is having liquid spring. It's on all four corners. It's a active suspension. You can go find a video on it to learn more about it. But anyway, it gives us a ride height plus or minus 4 inches of travel, which is fantastic. As we were driving around on the worst roads in the country, we had a really good chance to test it out. We were all super impressed with how much it would just float over rough terrain. And when we were driving on washboard, we found that if it was about, 50 miles an hour is actually a really good speed. Just kind of float over the washboard. You'd hardly even know you were driving on it. If you go too slow, that's when it really started bouncing around, but that's when the chassis had time to react and move. But it did a really good job absorbing the road dynamics, performed super well. No issues with it at all. One thing we noticed about it is that the valves on there are normally open. So when we would set up at night, overnight, the temperatures would usually drop, and then the valves would either leak just a tiny bit back to the reservoir, or the fluid would cool, and the chassis would lower down. So once we knew that, it wasn't a big deal. We could take care of it by just setting it low. But that's one thing that we noticed. They have a new add-on to the system. I think they call it camp mode or something, and it switches around so the valves are normally closed, so that when it self-levels at camp at night, it won't drift down. So I hope to get that approved in our budget at some point and add that. It'll be really nice to have, but really leveling wasn't that bad. If anything, we just have to do a little front to back leveling, and that was pretty simple to do with this system, because you can raise or lower the system, and it does, I think, the back first and then the front. So I could just turn it off whenever it adjusted appropriately, or we would just put the traction boards underneath it. So again, not a big deal. I think we could live without the self-leveling system, but it would be nice if the system didn't change overnight with temperature. The mud flaps that we have on here, we actually just fabbed up ourselves. We were looking around online for solutions to keep too much from getting kicked up along the rocker panel and onto the box, and nobody really had any answers for us. So we just made our own. Actually, it's a project I had the kids do. They did a nice job. So this is nothing more than 1/8 inch starboard. It's HDPE plastic. You can get it at hardware stores. It's pretty cheap. It's easy to cut. And because it's cheap, you can just buy a 4x4 or 4x8 sheet and just try some things, and that's really all we did. This is the first try, but we just took a piece and slid it up between the DBL fender flare and this inner liner, which is actually the same material, and played around with the heights, and it worked out really well. So functionally, because I'm an engineer, you're going to get engineering explanations. For the most part, anything that comes off the wheel at a tangent line to here, above that line is where your truck is protected. We just put it down as low as we thought we could go, and I don't think they ever caught anything, so it really wasn't a problem, but they did a really good job keeping things off the truck. So back here, and we've been out driving some more, so there's dirt on here, which there should be, but we didn't have any real mud buildup along here at all. Just back here we got some, and then when we were doing cornering and mud, then we'd get some that would go up the wall a little bit. And again, the truck's pretty dirty right now, but it's a truck, it gets used, it's supposed to have dirt on it. So anyway, a little minor detail, but it worked out really well. We thought we were going to have to do rhino lining kind of along here. I think it's probably just a waste of money, because I think it's going to be just fine as it is. All right, storage boxes. You just need lots of volume if you're traveling. You've got tools, supplies, just extra room to throw things. The worst thing I think you can do in traveling is fill up all of your volume, because then when you need to get to things, it's always unpack and repack it, and nobody has time for that. You ended up kind of getting more disorganized as you go, so you just need room to throw things in there. So we wanted huge storage boxes, and these are as large as we could possibly make. Spent a lot of time thinking about how low we could get for ground clearance, and this worked out super well. We never hit anything or came close to it. I think it's a great height. There's another reason that they're this deep, which we'll get to on the other side of the truck, but they worked out really well. So these are all aluminum construction. Designed these up and had them laser cut, formed, powder coated, welded, etc. Found these really cool handles. I'll do a little more detail on these in a minute. They're just standard handles like this. So there's a gasket around the opening, lanyards to tether, keep the door horizontal. This rear cabinet is used for traction boards, an extension ladder, these little collapsible bins we would usually put recycling in or things to keep it clean. This is our step assembly, and I'm going to take that out here in a second and show you how we get into the box. But I wanted to show you the quick layout. So 45 degrees back here, and then 30 degrees here, which brings this corner in a little bit farther, and I think just fits nicer, fits the profile of the tire a little bit better, and of course gives you more volume in the storage box. All right, so here's how we deploy the stairs. Open up this storage box, and I've got a release pin. This is actually on a drawer slide. So this is our front step. Thought long and hard about how to get this stair and step assembly integrated in the truck, especially with our door placement. I don't see a lot of other trucks with the door placed here. It's usually in the far back or the front corner, and we went in the middle, and you'll see the layout inside at some point. But these drawer slides are aluminum, and I think they have 700-pound capacity or something. It's kind of a crazy high. I wasn't sure how they would perform with getting dirt in there, and dirt certainly gets in there despite our effort to kind of mask it off, but just brushing it out or hitting it with some compressed air cleared the junk out of there, and it, grates a little bit. They're not going to have tons of cycles on them. I think they'll last long enough. But anyway, they're pretty good. So this is a big welded fender assembly. All right, so this is 1/8 inch aluminum. Actually, no, these are 3/16 aluminum. And then we did get some rhino lining put on the top surface for anti-slip, and then also sprayed the underside just to protect it from things getting kicked up from the wheels. And then you can see there's clearance there to slide over the tire. Okay, so now for the steps. All right, so this is the step assembly. I didn't have a lot of time to design this, so I pretty much designed it up and then got parts made because we're running out of time, had to get on the road. So this is all aluminum stringers and then a little cleat on here. So there's a little screw with some washers. that cleats on there like that, and then these parallelogram open. So that's the steer assembly. If the truck is raised or lowered, this just simply adjusts like that. So these are all, of course, rhino lined as well, and it worked pretty well. So there's some flex to it. It's aluminum, but I think there's plenty of load rating to it, and worked pretty well. So there's room up here to set your shoes over here and leave them outside on the front step. And if I back up and open up the door, we've got some Froley door latches, the magnetic ones. I put 2 on there because I really didn't want to have the wind ever blow the door open. Anyway, it also gives you some space to step out here and grab on the door and pull it closed. But worked really well. All right, so this storage box I opened up, and I have a release pin that's a spring-loaded pin that pulls out, and that's what goes into a receiver hole up here. That keeps the drawer slide in while we're driving. So I just open up that to unlock it. One of the things I was kind of going for is to have as much hidden and behind keyed doors as possible. So there's no way somebody would even know that this is a drawer slide or be able to pull it out. So it's only accessed when this box is open. So that's right up here. Like I said, it's a little grubby right now. We still have some wiring to clean up and things, but here's the pin. We ended up getting a Traeger grill. Really like that. We've got a 120 volt outlet in this box. So I would just pull this grill out and set it up right here. And then it was a good spot to cook fish and things. And it was also a quick reach into the kitchen as needed. The future plans for this are probably to put it on a drawer slide, so it'll just slide right out. Otherwise, you're just gonna have to move it around. It's not a big deal. So in here, we have a 120 volt outlet. We also have a Sterling DC to DC charger. So we have solar on the top, and we've got charging from the engine. So this one, we have a 48 volt system. This one is a 12 to 48 volt DC charge controller. And I forget how much power that one generates, but we'll put that in the comments or in the video. But it just kind of does its thing. It's pretty easy. So that's where we parked that. It's got a loud fan, and it's supposed to be protected, so you can't have it under the chassis or anything. So we put it inside the storage box. There's definitely enough room in here and aluminum to dissipate the heat, so that wasn't an issue. So the rear end, there's a few things going on that I wanted to talk about. One of the main ones is how we stored our spare tire. We had, in our first video, I talked about having our second fuel tank in a storage box, and I found out that that's a bad idea, just for safety reasons and just a whole bunch of other things. Turns out fuel systems are really complicated and messy, and it's just really hard to do anything to change them. So we really tried to work with what was there. What that meant is originally the spare tire was going to go where the OEM fuel tank is, up underneath the chassis. That didn't work out. We kept the fuel tank, and again, I'll talk about that a little bit more. So I needed to find a last minute place to put a ginormous tire. So it's 12 inches wide, 41 inches in diameter. It's 275 pounds. It's not something you can just really find a place to put it. And so after talking through some ideas with friends, we came up with this idea. So how this works is the tire has a bit of an aluminum cage around it. So this right here is one piece, and then there's another part on the back side of the tire that you can't see. And that kind of captures it and is bolted together. That assembly is hinged right here. So there's a hitch pin, and when it's released, it pivots about here, and the whole tire just drops down onto the ground. At least this corner will drop down onto the ground. At that point, you can kind of take it off of here and then move it around to where you might need to place it for changing a spare, changing the tire. We'll do this sequence at some point. I'm not going to do it today, so we'll show you later, but I just wanted to talk through it. So the way it works is that this upper pin is holding the tire assembly to the truck with this bracket. That pin comes out. The rear winch is actually lifting the tire up into place. So once that pin is removed, I can use the winch to lower the tire down slowly, and that way it doesn't have to be done by brute force. And then this is a receiver pin here, and there's another weldment in there. Again, we'll go over that detail more another time. This is the OEM backup camera. So this harness goes through the center of the tire to the backup camera here. So I do have to disconnect that to get the tire off, but that's pretty minor. That sounds involved, but the first time we did it, when we were trying to do our tire rotation, it only took like 5 minutes. So it's really not a big deal. There's no lifting it down from super high up on your truck, and overall really happy with this position. There just aren't a lot of good places to put huge spare tires, and instead we chose to build a big bike storage box, which I'll talk about here in a second. So one of the key ingredients of a build like this is a torsion frame, and I spent a lot of time analyzing and thinking about how to go about it. There's a few ways to do them that are kind of tried and true, including 3-point, 4-point, and rail-on-rail, kind of the main categories. We ended up doing a rail-on-rail assembly. That allowed us to keep the overall height that the torsion frame consumed as low as possible, and I think keeps the truck or in the box together at the right times for better stability to minimize body roll. It's all covered up and it's hard to see. We're going to throw in some pictures of what it was like when we were building it, but there's a big weldment that has the rear bumper on it, and then 2 rails that go and sit on the truck frame. The front of the torsion frame is constrained right behind the cab. There are 2 pivot points there with some compliance, but really that's the main anchoring point. The rails sit on top of the truck all the way back to here, and then behind these storage boxes there are 2 little brackets surrounding some UHMW blocks which are bolted to the truck frame, and those prevent movement front to back and side to side, but allows the truck frame to separate from the torsion frame vertically or twisting. So the function is pretty straightforward, but there are a lot of subtleties to make this something that you can actually manufacture, maintain, assemble, has the right properties of stiffness, and doesn't transfer any load from the chassis into the box. Super, super critical. These fiberglass boxes, or any box, if it's well made, is going to be extremely rigid, so you do not want to flex the box at all. So in this case, the box is bolted firmly and essentially permanently to the torsion frame, and then the torsion frame sits on top of the truck frame, and again, the pivot point in the front keeps everything together, and then it can float in the back. So what happens is the 2 rail-on-rail assemblies basically allow the rear tire on one corner to drop into a hole and separate and cause a separation. So on the driver's side, this tire went down into a hole, the frame would separate, but the load would be carried along the front behind the cab and along the passenger side rail. So that's kind of in a nutshell how it operates, but again, there's a lot to it. I did a lot of FEA on this one, which is finite element analysis, to predict how much twist that subframe would have under load. So with this design, I think I got it to where with a fully loaded box, we would only have maybe an 1/8 inch of twist to the frame. It's almost impossible to get to 0. It's just too heavy and too expensive. So I thought that was sufficient. A lot of the frames that I saw are way smaller than this, and they do a lot of things that are just not good for torsional rigidity. So this one has 2 steel tubes going front to back, welded to a front cross piece. The torsional stiffness of those square tubes really drives how well your frame is going to perform. These are large. They're 1/4 inch wall thickness, and they are 5x7 tubes. I've seen as little as 3x4, and it's just nowhere enough to keep your frame from twisting. So they're thick, they're heavy, they're complicated, but they're absolutely critical.